The lesson topic for this video is Applications of Quadratics, Part 3. Alright, now the last couple of lessons we've done on applications of quadratics, we have looked at geometry applications. This lesson is going to be something different. Alright, so this time we are going to apply quadratics in a different kind of situation, and instead of a geometry situation that we have to write the equation ourselves and then use our graphing calculator to solve, we're going to be given the equation right off the bat. So let's take a look at this, this first example. It says, you drop your keys from a window to your friend. The keys follow a path mapped by the equation y equals negative 16x squared plus 30, where x is seconds and y is height in feet. Alright, so what we're going to do is we're going to start right away by putting this into our calculator for y1. Alright, so we don't have to come up with the equation ourselves, we already have it. So go ahead and put that in your calculator and then graph it and see what it looks like, and then we're going to talk about what to do next. Okay, so here's what your graph should look like on your graphing calculator. It's kind of hard to tell what the parabola looks like right now. So we're going to really work hard in this unit on, or in this lesson, on figuring out what window will help us. And to do so, we're going to jump back up here and we're going to think about what x and y represent in this problem. X right here says x is in seconds, which means it's time in seconds, right? And y is height in feet. So height of the keys in feet. All right, so if we're going to change our window to try to see this parabola a little bit better, we know it's a parabola because it has an x squared here as its highest exponent. How does this parabola look? Well, let's think about that it's showing us on this graph down here that the keys are starting on the y-axis, the height. The keys are starting up here somewhere, and then they're falling, the height is falling as the time goes by, and then what happens is the keys actually land right here, because the height would be 0. They land right here after a few seconds. Now, how many seconds? Well, look at that. It's less than 2 seconds that it takes. You can see that by looking at what x is. So if I go into my window on my graphing calculator, we're going to want to change, think about looking at x min, x max, y min, and y max. All right, so our x minimum, well, our x is time. Time doesn't need to be negative. Now we can leave that at negative 10 just so we kind of can see a little bit on the other side of the y-axis, just because it's kind of good for our brains to see that. So we can leave that, but our x maximum for how much time has gone by, well, we can see that the keys fall less than 2 seconds after they are dropped. So we can make that x maximum be a lot smaller, maybe 4. Because we don't have to go, I don't like to go all the way down to 2, but if we look at 4, that might be a good, good visual for us. Then if we change our y minimum, well, our y minimum means how low do the keys go. Again, the keys aren't going to fall further than the ground. Again, this is a height of 0 here from where they started, but I do like to see a little bit lower down there. So we could leave that at negative 10, or we could make it negative 5 or something like that. But I don't like to use 0 because I like to be able to visualize it. Then our y maximum. Well, our y maximum is the one we really want to think about here. The y maximum is up here somewhere. And we know that it's the height in feet that you're dropping your keys from a window. So how many feet up might you be? Okay, you got to think about that a little bit. You're not going to be 2,000 feet in the air if you're dropping keys from a window to your friend. But you might be, I don't know, 50 feet? Who knows? Let's try 50, okay? So go ahead and change your graphing calculator to use this window, and then hit graph again. Okay, so this is what we get when we graph it again, when we use a different window. Obviously, I didn't have to go so far on my x minimum. That's kind of ridiculous, but that's okay. So we do see, however, the maximum point that the keys were at right here. Here's our parabola. We can tell what it looks like now. This is the maximum point that the keys were at, the height, and then they are dropping on the y-axis as the time goes forward. Again, we know that the time isn't even at 2 seconds by the time the keys reach a height of 0, which means they land on the ground. So this right here is the path of the keys, right there. The rest of the parabola in this picture doesn't have anything to do with a true word problem in real life. There is nothing over here at negative number of seconds, okay, in this situation. So again, the keys start here, and then they drop to here. All right, so the question is, suppose your friend misses the catch. Okay, so they didn't catch it, they landed on the ground, the keys. How long did the keys take to hit the ground? Well, again, really focusing on X and Y here. What are we solving for? How long did the keys take to hit the ground? We're trying to find what variable, X or Y? Well, we're trying to find X, how long the keys took to hit the ground. So if we're trying to find X, we need to know a value for Y. Well, we do know this value for Y. When the keys are on the ground, what's our Y value? Well, it's 0. So we want to know what is X when Y is 0. So we already know how to solve that because we've been practicing in class with our graphing calculators. We know how to solve that by putting a 0 in for Y2 and then finding where that horizontal line at 0, here would be the horizontal line at 0, where that crosses our parabola. So we need to find this value. Again, not this one over here, but this one over here. So I'm going to hit F5, F5 after I put that 0 in for Y. And my calculator does start with this value here, negative 1.369. That's not going to be a helpful value, so we're going to go over to the other intersection point, and we find out that X is 1.369. And we knew it was going to be less than 2 seconds because we had talked about that a few times. So I'm going to go ahead and, never mind, I can't. But here's where 2 was. Well, we know it's less than 2 seconds. So it only took 1.369 seconds for those keys to land on the ground. The second part of the question says, suppose your friend caught the keys 5 feet above the ground. So they caught them in the air. How long did it take for the keys to reach her? Again, how long did it take is an X value when our Y value is 5 feet above the ground. That means that your friend is probably standing here. Can you see my little person I'm drawing here? And catches them 5 feet above the ground. So right in there, right? They caught them about 5 feet above the ground. So now if I went through and I graphed that horizontal line at Y equals 5, because 5 feet above the ground, that would be somewhere in here. And we're going to find again that intersection point right there. So now I'm going to go back to my Y2 and put a 5 in there and then graph it and again find the intersection of the two lines. Make sure you use the positive answer. The positive answer here is 1.25. So again, it took less time for it, of course, to reach your friend at 5 feet above the ground than it took to land on the ground. So that's our first example. It takes a little explaining, especially when it comes to the window, and more practice on the next example. Okay, so this one says, during a chemistry experiment, the cork in a 6-inch or 0.5 foot or feet tall beaker with an effervescent solution pops off. All right, so think about chemistry here. You've got some kind of beaker with a solution in it, and there's a cork on the top of it. Okay, it's a 6-inch tall beaker. The cork follows a path modeled with this equation right here, where X represents the number of seconds and Y represents the height. So again, we have seconds or time, and we've got height for our X and Y. Good thing to always write down is what your X and Y represent. All right, so go ahead again and put this equation into your graphing calculator, delete the previous equations, and let's take a look at the graph. All right, so if we look at the graph, and I went back to a standard window, and that's one thing you might want to continue to do if you're on a Casio, that's F3 when you're in the graphing window, and TI people, that is Zoom 6 for standard window. All right, so we can see this parabola pretty well right now. If we wanted to zoom in a little bit, we could reduce our X minimum. We could reduce our x maximum, we could reduce our y here and really focus in on the part of the parabola that we're dealing with. Okay, so I've done that right here. I've just made this a little bit more zoomed in. I went -5 to 5, -5 to 5 here, kept this at 10 and went to -5 here. So again, this is how the cork is going to end up popping off that beaker when the solution forms enough air in the beaker to pop it off, right? So if we think about it, that means that it's sitting, the cork is currently on the bottle here, it shoots off and it comes up here, and then it comes and lands on the ground right here, or the table, I suppose it's probably on. So how many seconds does it take the cork to hit the table? Again, how many seconds means we're going to be solving for x, and we know what y is. What is the y value when that cork hits the table right here? Well, the height for y is 0 when it hits the table. So again, we're going to put a 0 in for y2, and we're going to find the intersection of the parabola with 0 for our y value. Okay? Right? So F5, F5 if you have a Casio, or second intersect, second calculate intersect. Make sure you go to the positive value once again, and our positive value is 1.275. So that's how many seconds it takes for the cork to pop off and then land on the table. Let's talk about the second one here. What is the maximum height? What is the maximum height that the cork reaches? All right, well, the maximum height, first of all, know that we are solving for y, because we're trying to find the height for the maximum height. But this time, we don't have really a specific x value to put in right now, because the maximum height is this point up here, right? This point right here is the maximum, and we learned how to find that maximum point in a previous lesson, which means we're going to, again, either use second calculate if you have a TI, or you're going to go to F5, and you're going to hit maximum for that. Now make sure when you do that, you've already taken your y equals 0 out of y2 in your y equals menu. So get rid of that 0. Go back through and then find F5 or second calculate the maximum, and the maximum is 6.75 for its height. So this ends up being 6.75 for the y value. 6.75 is the tallest height that the cork reaches. When does the cork reach that height? Well, that's actually our answer for x here. X equals 0.625. And that, again, would be the x value that's listed right here for the maximum, and the y value was 6.75 here. So when you find that maximum, you're finding two values, the time for x in seconds and the y value, the height of that point. So our answer for height here and our answer for the time there. All right, so more practice on this in class.